when we look at the social impact of information system failures in the study of Tetsuo Tamai in 2009, he underlines this, and he claims that computer-based systems usually work in silence when nothing goes wrong. No one says something nice, right? I mean, oh, it's working very well, doing millions of operations with no error or something. But there's a loud outcry when some troubles occur. That's, I think, that's the case for most of the professions, I think, and it relates to computers software as well. So this gives the general public the wrong impression that computer systems are highly unreliable. You see, this is another side of the coin, another approach by Tetsuo Tamai. And because why is it like this? Software is invisible and not easy for ordinary people to understand, because they do not understand this in their, or use this or hold this in their daily lives. And now let's take a look at the computer simulations. Computer systems and software behind locked rooms can also cause harm. Not only embedded systems, this type of software can also cause harm. What does it do? Resulting in poorly designed products, mediocre science, bad policy decisions, and much else, and lots of things. Computer simulations, in fact, have a key role. This is extra. Have a key role in science and engineering because of the limits on physical experiments, for example, and applications. It can be too expensive. It can be too time-consuming, it can be completely unethical, or it can be impossible at all. So you, instead of doing the real thing, you rely on simulations. In fact, they're very useful. Where are they used in that sense? They are used in nuclear weapons research, oil search before digging, right? And creating pharmaceuticals for drug science, and designing better cars, for example. We make for safety simulations, for example. Where do we use the simulations? For modeling past events. For example, astrophysicists work on theories on evolution of universe, etc. They do this for modeling past events. Or we use simulations for understanding the world around us. Geologists explore around for oil search because it's quite expensive. They set networks of microphones and use explosives to model to understand the world around us. Then they use the graphical representations of rock formations. The scientists use simulations for the earthquakes as well. I mean, God forbid, we had a very bad earthquake in Izmir recently, and the earthquake scientists, the scientists who work on earthquakes, are also rely on simulations for understanding the world around us as well. This is also, the earthquake could be another example in this issue. And we use simulations for predicting future. For example, weather predictions, economical predictions, also soccer predictions, okay, or for example, USA election predictions, whatever, okay. We do this for this purpose as well. So simulations may lead to erroneous results as well. We hope them to give us the best results, but it can also lead us in the wrong way. It can happen. So how do we know, our simulation programs, our simulation models are good? This is exactly the same as what we do in software, because they're software, right? So, and for software, validation and verification is important. Let's just remember them. I know you discussed this in software engineering. Software verification is, does the program correctly implement the model? And in other words, it is, are we doing the product right? Are we doing the product in the right methodology? We're trying to answer this question. And software validation is far more important, maybe. Does the model accurately represent the real system? So this is very important. Are we doing the right product? Maybe this can be very important for you as an undergrad student, but in real life, this one is much more important to model the reality, correctly. Maybe this is my idea. Okay, my call. So validating is done by duplicating the performance of the actual system. For example, for car safety purposes, they crash the real cars, comparing the model predictions, which one is more safer, which one will result in less casualties and less human injury, for example. It's important. And validating a model that predicts the future can introduce new difficulties because you're trying to predict the future here. For tomorrow's weather forecast, it may not be an issue because you can compare with the real value directly. Just wait for tomorrow and you can check your performance directly tomorrow. But how about if you make a study on global warming model for more than 50 years, for example? Now, you cannot wait for 50 years, obviously, to check the validity of your simulation model. Instead, you can predict the present. This is the approach for future predictions. Suppose that you have 75 years of data going back, and you use the last 25 years for target prediction and use only 50 years of data for the model, for example. Suppose that you have 75 years of data. This 50 years will be used as training, for example, training your system. And this 25 years will be used for testing how well your system performs, for example. This is called predict the present approach for validating a model that's predicting future. Of course, any type of simulation requires a credibility check by experts and decision makers as well, in order to identify how valid is your simulation model is. And let's talk about software warranties now. In Lewis and Turner's study, they argue that, which is pretty meaningful, I guess, there is always another software bug. It's like this security thing, computer security thing. We cannot talk about 100% security. We cannot say that we're 100% secure on the internet, for example. It's impossible to achieve. And for the software, we have a software that has 0% bugs. It's impossible again, I think. Maybe this analogy can hold. I don't know. So if perfect software is impossible, what kind of warranty should a consumer expect to get from a software company, for example? This can be an interesting question. And here we should underline the shrink-wrap warranties. Consumer software usually counted as shrink-wrap software because this name comes from its plastic wrap, but of course we have software from internet now. We do not get it like in plastic wraps, but that's the idea about its name. We're talking about the end user here. And not too many years ago, manufacturers provide no warranty at all. It was pretty common. But today, many software manufacturers, including Microsoft, provide 90-day replacement or money-back guarantee if the program, fails. Okay, that's that. But what do we mean by failure is another discussion. For example, at least Microsoft Office states that the software will do more or less what written in its documentation. It will do something like this. However, for example, in the software warranty or document of Railroad Tycoon game, for example, they can just replace the broken storage medium, or it cannot be installed. That's it. They do not. You cannot expect something more in this sense. So this is called limited warranty. Most vendors may be willing to give you a refund if you cannot get their software to be installed in your device. That's it, nothing else. And they, of course, don't accept any liability for your business gets harmed because of crashes, etc. They don't care about this. In other words, This is a nice saying from the textbook. Don't blame us if the program doesn't do what you hoped it would do, or if it crashes all the time, or if it's full of bugs. So, I mean, what kind of warranty is this? Just installation or broken medium, that's it. That's the case. And are software warranties enforceable? Let's look at this. In United States, you cannot put an unfair warranty for a product that costs more than $25. It's in their legal system, but in Turkey, of course, that's different. If you consider a computer program as a product, hence unfair warranties on shrink-wrap software could be a violation of the law as well. There are many trials held, but different laws in different countries, of course, in even different states of United States as well. And what can be the moral responsibilities of software manufacturers in this sense? If we consider software manufacturers of shrink-wrap software liable for the damages or damages caused by the errors encountered by licenses, if we dream about a world like this, what happens? They will be huge test teams, software testers in their companies, and there will be much higher prices and longer program development periods for a software to be put on market. Because today, manufacturers rely on customers for fixing bugs. They first release the software, then they get the feedback or testing from the customers, end users directly. So that decreases the costs and results in a very fast market production, right? And plus, if you have an ideal world like this, where they will be held responsible, they will also add the insurance to protect them from insurance costs, to protect them from the lawsuits as well. Usually these are very expensive, and this cost will also be shared by the customers as well. Okay, we always pay the price, right? The end users. And small startup software companies in this software industry will be much more affected when large, well-established corporations compared to them. I mean, because they will have lots of money and lots of lawyers here. So this slows the entry of new companies in the field, decreasing the level of innovation, competition, and vitality in software industry. We can conclude this. This is taken from the text as well. And however, consumers will have a confidence in software they bought. There will be much fewer products, alternatives, and there will be very high prices, but okay, in the end, those software would be much more reliable. Now, utilitarian analysis may conclude for current scheme, what we're doing now could be much more efficient in this sense. And however, consider this hypothetical scenario. Consumer buys a game named Incredible Bulk for $50, for example. And the game is playable but have some annoying bugs, right? This happens to all of us all the time. But next year comes Incredible Bulk 2. So consumer wants to see the bugs fixed in this version of software that he bought already. But he buys the new version, right? There are also new features here, and they're resulting in new bugs as well. Some of them bugs here are fixed in Incredible Bulk 2, not in 1. That's the idea. Now we can say that, okay, there's something wrong here, and don't worry, because next year those new bugs will be fixed in Incredible Bulk 3, and you need to pay for it another $50 again. That's the idea. They're just draining your money in this sense. Is this a fair arrangement? Just pause the video and think about it, whether it is a fair arrangement or not. Okay. From social contract theory perspective, it is unfair. We have the right to know about bugs in an open fair contract, and manufacturer should be open about disclosing weaknesses in its product and applying the patches as well, fixing those bugs as well. Consumer organizations test products for potential buyers by publishing reviews. This is very common. And consumer purchases the right to use product A. The manufacturer has to remove the defects without enforcing a purchase of additional features, or all of the updates should be patched for free on the internet. Withholding patches until the next major release is wrong in the social contract theory point of view. Okay, these are my references, and today we talked about computer reliability, a very, very important session in this